A lunar lander is to be placed in orbit around the moon at a mean altitude of 100 kilometers. What will the period be of the lunar lander? Use the above chart for reference.
In this diagram, we can see the moon with radius r and the green line that represents the orbit of the lander. The distance between the lander and the moon is 100 kilometers, and there's the force big G. The altitude is given to us as 100 kilometers, which is equal to 100,000 meters. The radius of the moon is 1.74 times 10 to the 6 meters, and the mass of the moon is 7.34 times 10 to the 22 kilograms. The G constant is equal to 6.67 times 10 to the negative 11, and we need to solve for T. For these problems, we always start with Fc equals mac. The only force acting upon the lander is F big G, so Fc is equal to F big G. F big G is equal to G m1 m2 over r squared, and mac is equal to 4 pi squared m2 r over t squared. The lander is orbiting the moon, so m1 is the mass of the moon and m2 is the mass of the lander. And we can now cancel out the mass of the lander. So now we can sub in the values of g and the mass of the moon into the equation, but we still need to solve for the radius of the orbit. This can be found by adding the radius of the moon to the altitude. The final value for the radius of the orbit is 1,840,000 meters. And now sub this value in for r. Now that we've found r, we can simplify both sides of the equation and rearrange the formula to solve for t squared. Now that we have t squared, we can square root this value to find the value of t. The final value of t in scientific notation is 7.09 times 10 to the 3 seconds. Therefore, the period of the lander is 7.09 times 10 to the 3 seconds. That's how long it'll take the lander to orbit the moon once.
We did it!